All right, so made a little bit of progress on the guitar amp. First thing I did was I took this transformer and cleaned it up a little bit and put some paint on it. Not perfect, but looks a heck of a lot better than it did. Cleaned up the leads a little bit. And got our power supply transformer. And most importantly, we got started with a schematic. Now, this is very preliminary. And as you can see, I've already gone through and highlighted some of the components that I know are probably going to need tweaked. The ideal situation here for this would be around a 300 to 350 to 355 volt B plus for all this to kind of work out how we want it for the current and voltages and everything to be where they need to be. But the reality of it is this transformer has a lot higher output than that. And like I said, I'm going to try not to purchase anything, so rather than buying another transformer, we're going to make do with what we have here. Now, that presents a few issues. Number one, we don't want to overdrive any of this circuit, so immediately we've got to kind of change our voltages here, so we may have to increase this a little bit and mess around with this a little bit to get everything where we want it. If you look at what I've done, this is a very simple single-ended circuit. I've only gone with a tone control and a volume control. I'm not going to get crazy with the bass and mid-range and treble and drive and all this other stuff. I think that kind of cloudies the water a little bit, and I want the guitar to be able to speak for itself through the amplifier and not be affected by a bunch of tone controls and things like that. You know, with the advent of modern effects pedals and things, if you really want to do that, certainly you could get an effects pedal for that. But kind of want to get that grungy blues kind of sound. I don't know anybody that plays guitar. I'm not a big guitar player really at all, but there's a sound that comes with this simplicity, and that's what I'm looking for here. So basically, very basic high gain preamp, 12AX7. You've seen this circuit a million times with the 100K plate resistor and the cathode biased. Pretty simple. Coupling it through a 0.1 capacitor. We need a lot of drive for a big tube, so that's why these are, usually you see these in the, 0.01 microfarad or 0.0047 or something like that, but we need the extra voltage and the extra frequency and so forth. So anyhow, where we have a little bit of differentness, is that a word? So pin 4 is your screen grid of your 6550 tube, all right? And normally there's a couple ways we can do this. If you want to run this tube in triode mode at a reduced power but less distortion, which I want some distortion, you can tie pin 4 to pin 3 pretty much and turn it into a triode. If you want to run it in tetrode mode, you can take a resistor such as this. Excuse me. Sorry about that. Nothing like having to sneeze when you're right in the middle of talking. Anyhow, we can take this pin 4 and run it through usually anywhere from a 47 ohm up to a 1K resistor and tie that into your B+. And that essentially will run it in tetrode mode. Now you'll get increased gain and increased wattage output, and you will also get distortion. You'll get higher distortion when you get the volume turned up. So again, pluses and minuses. The other way to do things would be if you had an ultralinear tap which is, you know, about 43% down, you know, of the windings, and you would take that into your tetrode, your screen grid, and that reduces distortion, but it also allows it to have the higher gain, the higher output, but it also thins the sound out a bit. So I did something a little different. We're basically using a voltage divider off of our B+, and we're kind of running this at about 69 to 70%, about 70% or so of the B+. And we're bypassing it with a cap. And this might make the sound a little bit more interesting. I've seen this before on other designs, and I'm kind of borrowing it from it. But I really haven't experimented with it before with any of my amps. So this is something I'm kind of looking forward to see how it sounds. If we get a balance of a little bit extra power, but a little more control over distortion and so forth and breakup, we'll see. So that's a little unique. Other than that, we have a basic cathode bias. And with this transformer, it's 400, 0, 400. So it's 800 volt center tap power transformer. And as you can see, it's pretty big, pretty good sized. So, kind of overkill for this design. But the neat thing is, if I like the design of this amp, I can double these tubes and put two of them in parallel with this same circuit. And I can then go to a larger output transformer later on, a larger single-ended transformer, get a higher output, make a bigger amp with just adding a tube and a transformer. So kind of like having the latitude to be able to expand. The only bad thing is when you rectify a transformer like this, you're going to almost have your peak voltage become your DC voltage. Now, of course, as you put a load on it, that loads it down. It's below peak. But if you take 400 volts and times that times 1.414, you get 565 volts. Now, it's not going to exactly make a 565 volt power supply. Right off the bat, using a 5U4, you're going to have about a 30 volt drop across there. And then as you pull current, and you level off these capacitors, that's going to drop even more. So realistically, this still can be 460 to 480 volts. So it's a substantial amount higher than the 355 that this is designed for. Now, we can bleed some of that off in a few different areas. We can certainly increase this to decrease the voltage down to where it needs to be for this circuit. So that kind of isolates that. This voltage divider will kind of take care of itself, as will all this. This tube can easily handle voltages upwards of 500 volts. So I'm not too concerned about that. However, this whole setup will throw off our biasing, so obviously this will probably end up, it could be upwards of a 470 ohm, and I'm going to go way up in wattage. I'll probably put a chassis mount resistor like a 10 or 15 watt, something like that. So we will have to play with this. And obviously these two capacitors here, we're going to let the smoke out of them if we make them 450 volts. So what I'll probably end up doing here is I'll probably take two 47s, put them in series, and put some bleeder resistors across them to equalize them, and then that'll give me about 22, 23 microfarads at 900 volts. So that's pretty easy. I have a lot of 47 ohm or 47 microfarad caps. So kind of like this, this is very small, 47 at 450. So I take two of those in series, and we got that. And I can also take a couple of 100 microfarad at 450s, which I do believe I have a couple of those. And you can see they're not much bigger than the 47s. You can see, not a huge big size difference. So I can double up on those. And so really those should be, now this one over here should be okay at 450 because of the drop of this resistor. I want to keep this voltage down in the 200 volt range, somewhere around there. So a couple components may need changed. This pi network, this is a resistor pi network. I may decide to go with a choke, although I have one choke. It's too big for this circuit and it's too expensive and I don't really want to use it on this, but we may be able to make something up. So again, I'm still tossed up whether I'm going to do a resistor pi network, which I probably will in the end, or a coil, an inductor. I've decided to, another thing I've not tried yet is elevating the 6.3 volts. Now this is a pretty common practice you see with some amp designs, because what happens is on some of these amps, depending on how high you float the cathode here, it is possible that there could be such a potential difference between the cathode and this, because normally you take the center tap to your 6.3 and you ground it for hum balance. The problem is the filament is very low resistance, so for all intents and purposes your filament is at ground potential. Your cathode, however, is way above ground potential. Okay, now in this case it's 14 volts, but remember we're putting higher voltage here. We may have to increase this, which is going to float this up. So we may just want to float this filament up somewhat to kind of get it raised above, closer to this cathode voltage. Okay, that's called elevated filament voltage. You can look it up. I think there's some articles on the internet. You can look that up. But essentially, what it does is it prevents any kind of migration, of the electrons between the filament and the cathode, and keeps you from having arcs or any kind of problems there. It could mess up your filament or your cathode if you get too big of a potential difference. So just something that we'll do. Now again, it just depends on how all this goes as to whether I'm going to use this or not, but I think I am going to elevate it some. Okay, and again, we have a 10-to-1 divider network. So if I have 400 volts there, I'm raising this up to about 40 volts. Okay, that might be a little high. I may have to tweak these. So again, another one that just might need to be adjusted. Okay, so you can see where we're standing here, and really all I'm going to do right now is I'm going to take the chassis, I'm going to punch it out, and I'll video that as I go along here. And when we punch this out, during this video here, this part right here, we're going to build this part out right here, the power supply. And we're going to kind of look at what we have to work with. Okay, get our final voltage here. My next step is I'm going to go from here to here and build this out. Now I want this pot to be in here because through this 4.7 I'm giving a return ground path to give grid leak for our grid. So I want this to be in here. And it doesn't matter whether it's down or up, but just so we have some bypass here. So I'm going to put that in and put this pot in. And then we're going to fire it up a second time. And we're going to take measurements all through here with the full voltage on it and see what we have to do with these resistors. Okay, so the goal is to just get this part to work. We know this is a pretty common circuit and we can get this working pretty easily. Right here's where all of our focus needs to be. So anyhow, that's what my aim is. And like I said, before I finish off this particular, this is what, part 2, because we did a part 1A. I kind of tagged it onto the back of the wood shop, or the shop tour video number 2, which I hope you guys didn't fall asleep through. But anyhow, when we're done with this part of the series, I will have the chassis punched out, and I will have power applied to this. I'll probably stop at that point, and then we'll go to part 3 where we'll do this. So, more to come later, and hang in there with me here. Alright, so step 1. Mounted the transformer here, our power supply. Starting to lay this thing out. And another thing I did was I pop riveted a couple little pieces of aluminum angle. This will be the top of the amplifier where the controls are up here. I'll clean that all up and polish it. And this is the bottom part. So this will be sitting in the amplifier this way with the speaker facing forward underneath. Tubes will be hanging out the bottom, and the back cover will cover up this. So all we got to do is pop the back panel off if we need to service the amplifier. And then the controls will be up here on the top. As you can see, all I really did was just drilled 4 holes in the corners, cut it out with a jigsaw with a metal cutting blade, and then just filed it to fine fit. So that's all there is to that. Now, the next thing I'm going to do is look at mounting the output transformer, which is probably going to go over here somewhere along here. And it will hang down from the bottom as well. And then the output tube and so forth will go next to it. So really we only have 3 tubes under here. We have the rectifier, which will be right around this area here in front of the transformer. We will have the output tube, the output transformer, and it'll be down here, and then the driver tube at the very other end. So that's where we're at, and once we get a little more punched out, we'll do another little shoot. Alright, little update here. Made a design change. Looking at it, I think what I'm going to do is I'm going to go more of the newer Fender tube amps, and we're going to make this go in this way, hanging down. And the controls are still going to be here, and this is going to be the back, but the tubes and transformers are going to hang down. I think it's going to make it a little bit better, a more compact amplifier when we get the chassis together and everything. And I think it's just going to make for a little better layout of the components and a little bit better dissipation of the heat from the tubes. So I think this is a little bit better way to go. So what I've done is I've just started laying out the chassis for the tubes. As you can see, it's going to look something like this. Okay, so here's your, how do you like this 5U4 out of a really old Seaberg jukebox. That's one of the things I learned early on. I have a cousin who's a lot older than me. I call him my uncle, actually. But he's one of the pioneers of electronics, truly. And he works on this kind of stuff, you know, and I kind of grew up learning from him how to work on a lot of this old equipment. Little kid going into bars at night to fix a jukebox machine or pinball machine or something. Great times. But anyhow, this is the layout that we're going to be looking at here. Okay. And our transformer is going to go here. And when I get a little more to show, I'll show you how I punch out these holes with the chassis punches. I also found this really cool tube, notice, from West Germany, 12AX7, great shape, so we're going to use this. Should sound good. So let me get out my punches and let's see about punching out this chassis. Alright, we're going to start out with the smallest hole, and Basically, we're just going to place this in the hole, and you can see, screw it together, crank it down, and it'll pop it right out. Now normally, I like to put the cutter head part on the top that you're going to see so that the edge of this doesn't put some little scratch marks around there, but I don't think it's going to do that much of a scratch mark. And number two, it's hard to reach in there with the wrench. Okay. And number three, this thing's going to be hanging upside down. It's not going to be like something sitting on top of a bench or something, so I'm not so worried about it. So let me get this put together. Okay, that's not working so good when I'm trying to do it in the blind. There we go. And you just kind of screw this down here till the cutter seats. And then we grab a wrench. And we just give this thing a good crank. And we have a perfect hole. And we'll mount it right up like that. So we're going to do this with the other two, and we should be ready to go here. Okay, I'll be back as soon as I do it. Well, since I'm using these radial leads instead of axial lead capacitors, I hate kind of hanging them that way off of terminal strips. So I thought I'd just take a few minutes and make a quick capacitor board. And what it's going to do is it's going to hold these two capacitors, which are going to be two 47s in series to get the voltage up, two 100s in series right here. I'm going to have some wires go off the board to go with this 15 watt chassis mount 200 ohm resistor. And I'm also going to put this resistor, which is going to end up being something different than this because of the voltage. I'll populate that once I figure it out. And this capacitor right here. So all that is going to go on this one little board, and I just put a couple little standoffs on it, you can see. And I'm going to attach it underneath the chassis, kind of like that. So it'll be, you know, hanging down that way, kind of that way underneath. So I'm going to solder the parts onto there, and that should make it a little bit better here, so a little neater. I just noticed this is really kind of close here, so I'm going to probably carve a little bit of this track out of here to give me more distance on there. And I may even paint a little bit of liquid tape or Corona dope or something in there to protect that. This one's got a pretty good distance, but that side there needs cut. So anyhow, I'm going to do that. I'm going to solder the parts on here, and we'll be well on our way to starting to wire up our power supply. So, by the way, this is really easy to do. All I did was I took just some vinyl tape like this, laid it out on here in strips, and I took a little bit of ferric chloride and just dipped it in there and etched the board. So you don't have to have a fancy CAD drawing or anything like that, just some tape and an X-Acto knife and a pair of scissors, and you can make really basic circuit boards as easy as that. Alright, and I just took, you know, a larger board. This came off a larger board, and I just scored it really well with a utility knife, and then snapped it off to get it to the size that I want. That's all there is to it. Real simple. And you can buy these little PC board kits at Radio Shack or online or whatever. So anyhow, just another little update. And here we are. So our voltage comes off the rectifier tube into here, goes through these two capacitors which are in series, which gives us our 20-some microfarads that we need at very high voltage. A couple of bleeder resistors and balancing resistors to make sure that the leakage of these is matched. Same thing on here. Goes through this, which is going to connect to this chassis mount pi resistor for the pi network. Goes into the larger caps and comes out of here with your B+. Then we go down through this resistor for our dropping resistor. I've increased that to a 200K, and once I get these values that I know they're correct, I'll change the schematic. And that'll be the dropping resistors for the preamp section. And another filter. And here we go with our output to the blue wire. There's our foil side, just a bunch of solder. Not bad. And I may clean off this flux. This is not corrosive flux, so it really wouldn't hurt to leave it on there. But I might as well spray it and clean it off. I just kind of prefer it to look a little neater. And then I'll mount it up in our mounting holes here. And our power supply should be ready to start wiring in and testing. Alright, we'll be back. Alright, here's where we are. We now have a power supply. I have the rectifier tube connected. Got all my high voltage. Got our board, all the parts fitted on that. Got the transformer wired up except for the 6.3 volts. And I got the power switch put in. And really I need to break this one circuit and put the fuse in line with it yet. I have not done that. I need to cut a fuse holder in there. I just haven't done it yet. And I did put power to it. And it is grossly way too high. Even with a load connected to it, it's still up over 500 volts, which I expected it to be. So I'm going to show you a little formula that I used to get an idea of what I need to do to drop the voltage down. And then we're going to, I've ordered some extra resistors to replace this one. I'm actually going to take this pi network resistor, and it's going to end up being somewhere around 2.4K. And that's going to get my voltage around where I want it. And we'll go through that here in a little bit. But I just wanted to show you an update on the power supply that's put together. It's coming along fine. And we'll go from there. So sit tight and we'll be right back. Alright, I'm going handheld here, so the camera's going to get a little shakier. But here's where we are. I have the amplifier, at least the output section, wired up. So if you look right here, this area here is all done. Right here, all I did was I just tacked a 470K resistor to ground to just allow some grid leak. And here's where we're at right now. I threw a KT88 tube in there, just a, a test one. It's actually an old KT100. And I've made a few little changes just right now to see what we get under load. And I put a 470K resistor for the bias resistor on the grid, or I mean on the cathode, for the cathode bias. It was 200. I moved it up to 470, so I a little more than doubled it. And let me put my meter up on the stand so you can see it a little easier. So right here, this meter is going to represent our grid voltage, or I mean our cathode voltage. And this one is going to be the actual plate voltage going into the plate. Now, I don't want to run this a whole lot because it is running a bit overload for what it should be. And I'm getting a little bit of hum, but not bad. So, now you see right now the voltage is real high. And that's going to come down as soon as that tube heats up. See it? There goes the KT88. It's dropping us down. And you can see here I'm getting cathode voltage. Now don't worry about this. It's a big resistor in there, so it's going to be high. Alright. And I don't have my full 120. I have about a little, let's see what's on there. I'm running about 102. And if I bring this all the way up to 120, you can see I'm getting about 445 volts, about 440. And I'm getting about 34 volts on my cathode. Alright, so I'm turning it down right now. So 34 volts on the cathode at about 440 volts. So if we go 35 volts, right, 35 volts divided by 470, that gives us 74 milliamps, which is way, way, way too high. Now these tubes can handle, you know, upwards of, let's see, maximum filament current, absolute maximum. You can see, where are we at? 190 milliamps DC cathode current, but you certainly don't want to get anywhere near that. Typically, in a Class A amplifier, they want your current floating. Yeah, they're saying around 87 milliamps, so that's not too bad. DC plate current, zero signal. So that's not too shabby, actually. I thought that was kind of crazy numbers, but I guess it's not. That voltage is floating a little bit high. I'd like to cut that just a little bit. But everything's staying pretty cool, and it is biasing up. I didn't really want the 450 volts. That's a little bit hot, but not terrible. But I guess what I'm saying here is we have a working output circuit and a working power supply. Now what we're going to do now, in the next video, I'm going to end this video here. And here I go hitting the telephoto button again. So what I'm going to do here now is I'm going to cut this video right here and post it. And now that we have a kind of a functional output section, we're going to start tweaking it to get our numbers where we want. So essentially what we're going to adjust a little bit, and I'll unplug this. And yes, I have my watch on, and I'm staying out of here for that reason. I'm unplugged. You can see I only have 8 volts on my capacitors. And I'll use my little stinger stick here. And I will discharge the B+, which is just right over here. And you can see that's all discharged now. Okay. So there we go. And so basically we're going to tweak these numbers a little bit. So we're going to adjust our 470 cathode resistor, possibly, and we're going to check on the this little pi network resistor. I may raise that from a 200 ohm maybe to a 470 or something like that, but pretty close. None of these are getting warm at all. Definitely happy with my bias, even when it comes to my little voltage divider. This 470K, even though that's a 470 there, that's one of those old carbon comp, which is really good for high voltage. And it's reading a little bit high, because it's an old stock, new old stock resistor, and it's more like 500K, which for this instance doesn't really matter, so I thought to put it to a good use, you know. Everything else is well within tolerance, everything's staying nice and cool. So I guess the next thing is, like I said, adjust these two resistors, get our voltages a little bit more in line where we want them. We're pretty close already. And then we can start building out the preamp. So I'm going to post this up, and we'll be back next video. Thanks a lot.